In this video, I will be solving problem 3, and to begin this problem, it asks for a solution strategy. This circuit asks us to design a circuit that can add 9 input signals, A, B, C, D, E, F, G, H, I, and outputs the number of inputs that have a value of 1. So, in many ways, this is just basically asking me to straight up just add. Because the number of ones basically is the value that all these different 9 inputs will equal. So that's the first thing I notice about this problem. And so hopefully that's something you included on your solution strategy, is that basically all you're doing is trying to add these all together. You're not really trying to find the number of ones, per se, like exactly. And so the next thing I know is that basically I can, if all I want to do is add, I really only need full adders and half adders, so that additional gates restraint's not really that important. And so finally, what I would like to maybe show is kind of a little bit of my strategy for how I approach this. So essentially I've got A, B, C, D, E, F, G, H, I. And I'm adding them all together. Well, I know that with a full adder I can only add 3 bits together at a time, and with a half adder I can only add 2 bits together at a time. So essentially I kind of want to start by grouping my different variables together into full adder arrays. So I'm going to put these 3 into a full adder, and they're going to have a carryout bit, which I'm going to call C hat 1, and they're going to have a sum bit, S hat 1. And here, these are going to have a carryout bit as well, S hat bit. And then these finally go all together, C3 hat and S3 hat. I don't know why I wrote bars there, sorry. And then, so I've got 3 sum bits out. I need just 1 at this order of magnitude. So these sum bits are the same order of magnitude as the A, B, C, D, E, F, G, H, and I. So that works. And then if I add all these together into another adder, full adder, I get S hat 4 and C hat 4. And this is my next order of magnitude. My carryout bits are higher order of magnitude. And so S hat 4 is going to be my S0, 0 bit of my sum. And now I can add these 3 together and in one big full adder. So this will give me S hat 5 and C hat 5. And then, so this S hat 5 and C hat 4 are part of the same order of magnitude. So I can add these 2 together, have a single carryout. I only need a half adder for this, I think. Yeah, I should only need a half adder for this. So we'll put a circle here for half adder, and these will output S hat 6, which is going to be S1, and it's going to output C hat 6. And this will also only need a half adder. It will output C hat 7, which will be my S3, and the output of this is going to be a sum hat 7, so S2. So what I noticed is I need 5 full adders and 2 half adders, and basically I'm just going to design my circuit just like I did this addition. So this translates, so this is kind of my methodology, this is my step-by-step method, and so I'll have 1 full adder with inputs A, B, C in, C out, and sum. And basically now I know that all full adders have to maintain the same configuration, and I will only put a box of FAs to indicate that this is what I'm referring to. So for the first one, I'm going to put A and B in, and C in, and the next one I will put D and E in, and F into this. This is another full adder box. And then I need another full adder box where I will put G, H, and I in, and I'm going to dump all these into another full adder. And output some bit 0. And now each of these carryout bits, these top three are going to go into C1 hat, C2 hat, C3 hat, are going into another full adder. So I'm going to put a full adder here. Full adder. So this one goes here. This one goes here. This one goes here. And then I just need this C out to go into here, so we're going to have a half adder, and I need to relabel everything. So I'm going to label my half adders this way of A, B, half adder, C out, and S. So this is going to go into A, this is going to go into B, and this is going to come out to be my S1. And then I just need one more half adder. So C out's going to go into B, carry out from here is going to go in there, and then I get S2, and this carry out is going to become S3. So 5 full adders, 2 half adders.